The TI portal meets Git.
Hey everyone, in this video we'll talk about version control in TIA using the version control interface, Git, GitHub and the Git connector, and I'll also show you automation compare tool. So why would you need version control in TIA is the first question. Imagine you have a block that maybe controls a motor. When you do your first project, it's going to be a very simple block that maybe just sets this motor to work at different speeds. But the more projects you do, you will probably start reusing this block and you will be expanding it, adding extra functionality, maybe some alarms, maybe some safety, some extra inputs and outputs handling. This block will start growing. Now imagine there is more than one of you. Maybe you and 5 of your colleagues are developing different projects using the same blocks, to reuse, to not reinvent the wheel. You are reusing the blocks that each of you made. So this block starts growing and is being developed by multiple people at the same time. Now suddenly it stops working, or stops working as you would expect it to be. And how do you find who modified it last, what changes they made? Why is it not working? Why is it doing what it's doing? Well, these questions are the actual reasons why you need version control methods. And there are 3 things you can do regarding version control in TIA. First, and the most native thing, are the TIA libraries. So with TIA libraries, you can version control different objects in TIA, and it's great for having like copies of maybe even entire HMI or entire HMI screens, big objects in TIA. You can also version control different blocks, but the downside of the libraries is they don't really show you the exact changes between different revisions. So then we get to point 2. The second method of version control in TIA is what is now called project server. It used to be called multi-user server, and this method allows you to version control entire project. It's really good. It allows multiple users to develop one project simultaneously, so they can be online to a server at the same time, modify the project. You see who modified what and which blocks they changed. But this is for entire projects, so it's on the project level rather than on the block level. So the third method is what we'll discuss today, VCI, version control interface. It's something that you will use if you want to version control individual blocks. The great advantage of VCI is it will actually export your blocks as XML or .scl files to allow tools like Git, like GitHub, GitLab, to easily compare different revisions of files and to show you exactly what changed between them. It will also show you who modified it, what they modified, when they modified. You will be able to fork it, you will be able to merge different changes and track exactly what was happening to your blocks with descriptive comments. So this is what we're going to do today. First thing you'll do, we'll set up your environment. So we'll install Git for Windows and set it up. Then I'll show you how to use VCI in TIA portal. We'll set up ourselves a little repository on GitHub. We'll push our blocks from our local repository, from our PC, to the central repository in GitHub using the command line interface. Then I will show you the Git connector add-in to show you how to automate this process and how to control your Git not from command line, but directly from inside TIA. And the last thing, I will also show you a little program called ACT, Automation Compare Tool, that allows you to visually compare XML files. So rather than you reading the files and the contents, it looks at the file and actually shows you it nicely in ladder and flags up any changes between different files and revisions. Okay, let's start by installing Git. We can find Git, just go to your favorite web browser and look for Git for Windows. Then we go to gitforwindows.org webpage and we download the latest version of Git. Now, before you go on and start installing Git, the important thing is make sure that your TIA isn't turned on. If it is and you install Git while TIA is running, then you'll need to restart TIA for it to be able to pick up Git in your environment. So make sure that that TIA is not running when you're installing Git. In terms of the installation of Git itself, you should be just going through all the default options. And the one thing that I'm going to change is I'm going to change the text editor that Git uses as default. I'm going to change it from Vim to Visual Studio Code. But Any of them works perfectly fine. If you don't know which one you prefer, just stick with them. If you have any preference, you can choose it here. Go through all the default options, which should be good for most of people. If some of these options are not good for you, you'll most likely know about it, so there is no need to discuss. Quickly install Git, shouldn't take. Okay, Git is installed for us. Now, there are a few things that we'll need to set inside Git. Okay, let's fire up a command line. And what we'll need to do, we'll need to initialize our repository. So we'll need to create a local folder to which Git is going to connect, and it will be monitoring this space for us to then be able to push it to the central repository. Also, this folder will be used by TI itself. So we do git init, and we define where we want to create our local repository. So for me, it's C, and then I will create a new folder there called ti_ws for workspace. Yeah, so we initialize an empty Git repository there. If we now go to this place, to this PC, C, TI, as you can see, it's empty, but if you do hidden files, you can see that there are some files used by Git itself inside, okay? So we've done this. If we've never used Git before, what we'll also need to do, we'll need to define our username and our email. This is so that Git knows when it pushes the changes to a central repository, it will know who made these changes. So the commands we need to run here is we need to do git config global user.name. This is your username, might be first name, last name. I just use my first name. And then we do git config global.user.email, and here put your email address. Yeah, no dot here, so global space user.email. This should be fine. Our environment is more or less set up for using Git. Now we can go to TIA. Let's close this down. Let's fire up TIA v16. We have TIA running now. What we're going to do, we're going to open a previous project that we created when going through the scaling and processing of analog inputs. If you want to check out a video on this, if you're interested, you should now have the link above. Okay, just to recap, in our project we have an analog input scaling block that takes the analog input value, normalizes, and then scales it between our for our sensor range and gives us an output of scaled value. But the thing that we'll focus on today is the version control interface. So now imagine that you have this block and you start with something very basic like this, but throughout your projects you will be probably adding an extra functionality, maybe some extra thresholds to give you warnings, to give you alarms, etc. Now you'd like to track the changes to this block, so if something goes wrong you can always go back, you can see what was changed. Maybe if there is a team of you, your colleague makes a change, you make a change, you'd like an easy way to merge these changes together and again track what was happening with the project, throughout the development of your block, and keep comments about all the changes. This is exactly what version control means and is used for. So we now with version 16 have this version control interface where we can add a new workspace, and what it's going to do for us is when we defined a local workspace, and if you remember, 5 minutes ago, maybe even less, we create the workspace for Git. So here, this is the place where we should actually show it exactly same workspace. So both Git and TIA will share the same workspace for a project. So we go C, TI workspace, okay, and here we can select a version control add-in. This is something that we'll do just in a moment, but first I'd like to show you how you would work with version control interface without having the add-in, okay, so that you know how it works behind the scene. So we define our workspace, and then what the VCI actually allows us to do, it allows us to automatically export the program blocks to one common format, and this is a text format so that they can be easily cross-reference. So if we have different versions, we can see exactly what was changed. There is no way to do something like this normally, especially if you're talking about ladder blocks. SCL, quite easy. You can export the sources. Ladder, function block diagrams, not so much. So with the VCI, which uses openness in the background, we can actually do it. The way you do it, you define the blocks that you actually want to version control by dragging and dropping them. So we drag and drop our analog input scaling block. It will export it for us into XML format. For ladder, for function block diagrams, it will always be XML. For SCL, you have the choice. So it can either be exported as .scl, and then it just looks like your SCL, or it could be exported again as XML. Okay, so as you can see, it exported for us as XML. Now, if I go here, I have this XML file. I can open it and see how it looks like. So as you can see, it has information about TI version that we used. It then has information about our interface. Okay, so all the inputs, outputs with the commands. Then it will show you how the networks are being blocked. You can actually find more information about this XML format in the TI openness documentation, because this is what is being used here to export it as XML. But what it means is that we now have a format that we can use to export and import files. And with a text format like this, it's very, very easy to just see the differences. So for example, if I changed the input name, I would be able to see it clearly in a visual manner. What I can actually do here, let's call it maybe not raw value, but raw value underscore mod. Okay, and I save it. Let's see what happens in TI if I make the change to this exported block that sits in my workspace. If I go back here, I can see, oh, there's a difference. Okay, so there is a difference between these two blocks. Now, how can I see what the difference is? I actually have a little program called ACT Automation Comparator that allows me to visually see the differences between them, and at the end of this video I'll show you where to get it and how to install it in TI. For now, I just right click, compare to the workspace file, and use ACT for it. So it will fire up ACT for me, and it will show me that, yeah, this is the file that you have in your project. This is the modified file, and in red I can see, okay, the change here is that raw value was changed to be raw value underscore mod. The rest is exactly the same. So a very, very nice tool that shows you graphically the differences between the files that were exported as XML files. Okay, let's close it for now. We know what the differences are, and then you can decide, okay, so which one is the correct one? Do you want to import from the workspace, so like take the one with the mod, or do you want to export to the workspace, so override the mod with what you have in the project? I actually want to have what I have in my project, so I'm going to select the arrow pointing towards the workspace, and then I will hit the synchronize button, which again will override the file, and if I go back to it, reload it, again, it's just called raw value. So this is how you can see the differences. But all this is being done locally, okay? It's good, okay? I exported the files, I can see the differences. But how do I then send it to a central repository so that I can work with my colleagues on the same files? I have a central place for tracking it. This is where Git actually comes into play, okay? And we have different services for Git. We can use things like GitHub or GitLab would be the most popular ones. GitLab is great if you have a big organization maybe and want to set your own server, because you can just grab GitLab, install it on the server and use it for your organization. Or if you want, you can use something like GitHub, where you just register on the website and create yourself some repos. So this is what we are actually going to do. So we go to Chrome, we go to GitHub. Okay, and here, if you don't have a GitHub account, you can just sign up for it. There are different variants, but generally speaking, you can have a GitHub account for free with some limitations. I already have a GitHub account, so I'm just going to log in. And here you can actually create a new repository. So you just go, create new, give it a name. Let's just call it VCI. Okay. You can give it a description. Okay, this is going to be a public. Yeah, that's all good. Let's create a Git repository now. So it created us a repository, and here you actually have links that we'll need to use to commit to this repository. GitHub will also tell you what commands you need to use. So we already did git init. We won't bother with adding the README, but we need to commit the files that we have to our repository. So what we'll do, we'll fire up our source command line. We'll then we'll change the directory to go where our repository actually is. So we'll do cd c, where was it? TI workspace. Yeah. Now we'll add all the files that we have here. So we'll do git add all. Okay, so we added all the files that are in this repository. Now we're going to commit them. So git commit, and we'll call it initial commit analog input scaling. Yeah. Now we need to add the origin. So this way you need to go HTTPS or SSH if you have set it up, copy it, and we do git remote add origin. So this is how we just map our local repository to the central repository that sits on GitHub. And we do git push set upstream origin master. Normally, if you were not logged in, you would get a pop-up here asking you to log in. Then you can choose login with browser, and we verify that you actually have access to this repository before it allows you to push your changes. Okay, let's now go to our repository and see if anything changed here. As you can see, we have our initial commit with the comment and with the entire XML file. So everything worked fine. We're able to push our blog to the central repository, which now means that any future changes that we push here will be version control, which means that we can give access to other people and to maybe push their changes to this blog that we can then merge and version control everything that happens in this central repository. So next time, if I have a project which needs some analog input scaling, I can just create a workspace, pull down the latest version of this blog that might have been modified by my colleagues, and just use it in my future projects. Now, all this we did using the command line interface. How would we do it using the add-in that I mentioned before? If we go to the Siemens support website and look for TI add-ins. And if you want to learn more about add-ins, please check our other videos specifically on add-ins, also showing you a very, very cool add-in for FCFB conversion. So we go for the download of TI Portal add-ins, we scroll down and we download the VCI Git connector add-in and description, not necessarily the source code. I already downloaded it, so I should have it in my downloads. Just extract it, and then you will find an install instruction that will tell you, yeah, take the add-in and paste it there. So we copy the add-in with Ctrl+C, we go to the C drive, program files, Siemens, automation, Portal 16, add-ins, and copy and paste it here. I already have the add-in installed, but the way you will have it is it will appear here as deactivated. You can then right click, activate the add-in, and give it all the permissions. Okay, so again, follow the instruction, copy and paste the add-in to what the instruction tells you. Then in TIA, go to add-ins on the right hand side. You need V16 for it. Right click, activate, give it permissions. The add-in is installed and activated. Now, if you remember initially, when we set up our workspace in TIA, we said, yeah, no add-in. But now we can actually go and select version control add-in. What is going to happen now is if you right click something in your workspace, you have this extra menu for Git. So rather than you having to control Git from the command line, you can do everything with a GUI from TIA. Now in this GUI, there are two really interesting options. If you go to settings, you have commit on VCI synchronized and push on VCI synchronized. I used this add-in in the past, so this is why they're ticked. I think by default they are either both unticked or at least push is unticked. So let's untick them, which should match what you have, but just double check your settings because I honestly don't remember the default. So I'll untick these. They are now unticked. Yeah, so I have full manual control at this stage. So now let's imagine I have another block which is for analog output scaling. I synchronize this with my local repository. The Git add-in shouldn't be doing anything, but it will ask me for a commit message. And this is because every time I synchronize, this means, yeah, it's a different version, so it will want a commit message. So initial upload, maybe let's call it commit of analog output scaling block. Yeah. Okay. And now you can, for example, do a push. Okay, so if you don't have a manual push, you can do a push from here. Sorry, if you don't have an automatic push, you can do a push from here if by clicking right-click push. But generally speaking, I would probably recommend doing commit on VCI synchronize. It just saves you this one step, because every time you synchronize your changes in the project with the changes in the local repository, it's also going to create a commit for you. Maybe not necessarily push, maybe you don't want to push every time you synchronize to a local repository, but I leave this choice to you. So now I'm going to do right click and just push this thing. Yeah, it should have pushed this now. So if you go back to our VCI, we now have this analog output scaling block that we just pushed. Okay, so this is how easy it is to work with Git, with the VCI, and with the VCI Git connector. Now, it's not something that I would normally recommend, but let's try to modify this file here just to show you how you would grab the changes. Okay, so we edit this file in the browser and we change raw value to be raw value modified. Yeah, we give it a modified interface. We commit this directly to the master branch. Okay, so now this changed, and what I can do, I can right click, I can just get myself the latest version. So rather than pushing, I will want to pull it. Okay, so I'll pull the latest changes from the repository. This is something that you would do every time you probably start a project and you want to get the latest versions of your blocks. So we pull it. Now it tells us, okay, wait, there are differences between what is on the central repository and what you have in your project. Do you want to do something about it? Again, I could use ACT to see what the changes are. I see, okay, yeah, the change of this was modified. It is the correct way to go about it. So I want to import this from the workspace. I synchronize. And then if I go back to my analog output scaling block, it should now have the new name in its interface. So this is how you work with it. One last thing I promised to show you where to get ACT. So automation compare tool on the Siemens website. You just find it here. I include this video, this link in the video. You download this, and then you actually need to go to settings, version control interface. Okay, you scroll down here, and you need to add your program. So basically, you go here and you point it to your program. You click modify. And it then should appear whenever you have changes. You right click and show the changes with ACT. So again, if I make a change here, go back to my workspace, I can now right click, compare, use ACT. Yeah, do you want to compile? Yes. And again, it shows me where the changes are. If you have any questions around the version control interface, please do let me know in the comments below. Thanks and bye.